You. Hi. Yeah, you are here. Our guest today is Dave Nordentoft from Leister, and they are doing some really, really cool things with technology. I'm going to stop my share because I need to enable it for Dave to share. And I listened to this presentation just a little bit ago and was really super impressed with what they are doing with the technologies that they're using in the welder. I think you guys are going to be really impressed and probably have a lot of questions. So Dave, I'm going to let you introduce yourself, go through your presentation. If you have questions, you can drop them in the chat, or we will have a Q&A period at the end of Dave's presentation. So Dave, it's all yours.
Great. Thank you very much, everyone. I really appreciate the invitation and the opportunity to be with you today. Again, my name is Dave Nordentoft. I'm the manager of the roofing product category at Leister here in the United States. To give you a little bit of a background on me, I've been with Leister now for just a little bit over 9 years in this role. Primary responsibilities in a roofing category range from distribution and sales management to industry relations, ongoing training and education, and some marketing activities as well. I've been in the industry now for over 35 years in a variety of different roles. Quite a bit of time spent in material distribution here locally in the Chicago market, also in material manufacture, outside sales, and two-step distribution as well. So I'm kind of a lifer, and but I'm very grateful again for the opportunity to speak to this group today. Leister Technologies was founded and formed in 1949 by Carl Leister. And so we've been in business for quite a while. Our core competencies, I mean, most everybody knows us for the roofing industry that we serve, but we actually get involved in a lot of other different technologies and serve almost infinite number of industry sectors, utilizing primarily hot air technologies, for a range of different, welding applications and industrial applications, ranging from, infrared heating and also laser plastic welding technologies. We really cover a wide range. We now have 8 subsidiaries around the globe and sell products in over 100 different countries through 130 different distribution partners. So we're really global in scope. We cover a lot of different industries, a lot of different technologies all across the globe. So, but anyway, we're going to focus again today, though, on what we're doing here in the United States. So I'll go ahead and share my screen. So everybody see? Great, yes. Thank you. Okay, so today we're going to talk about some of the newer technologies that Leister has been bringing into the marketplace and some of our welders. We go back about as far as 2016, 2017, we first introduced the Leister Quality System, or what we call LQS. It didn't start off in the roofing category. We actually began this process in our geosynthetic welders. So if you're familiar at all with any geo products or geoliners. Now, these are membranes. They're still thermoplastic based, but they're utilized in primarily below grade applications for such things as waste containment, landfills, tunnel lining, and these sorts of things. And a lot of this was really born out of the need to, or the desire to try to provide additional data, information, and give contractors and installers the ability to improve the overall process, the welding process, by giving them information that they could have in real time, but also providing them the ability to archive their work and archive what they're doing. So in the geosynthetic domain, it's a much more heavily regulated industry, particularly in the European market, which again, we serve and have for a long, long time. So when we brought this LQS into these welders that weld these geomembranes, again, we thought all along there would be other applications and other industries and other ways that we could utilize technology. And it migrated into the roofing side of it around the end of 2021 and beginning of 2022, when we first launched our first welder in the roofing category that was LQS enabled. So we've been out, in the United States market now for just a little bit over a year with this technology. So I want to give you a little bit of background, high level overview of some of the key features of what's happening with this technology. And so let me go ahead and advance through this. So again, some of the key features of the number one, data recording. So what's happening in the background of any LQS-enabled machine is we are recording the key welding parameters, such as the temperature and the welding speed and the air volume. Every time that the nozzle is inserted and the welding process begins, that information is being recorded in the background on the machine. And the machine has in excess of 7 gigabytes of space on it. So there's the capacity to record thousands of records on the machine. And so we're tracking these key elements every single time that the nozzle is inserted. But we're also tracking another key thing that is really kind of the first time that we've been able to do this. We're tracking the incoming voltage that's coming into the welding machine. And what we have found in many instances where there's quality control problems or machine performance problems, it's tied to the power supply that's coming into the welding machine. So these are all machines that are operated on job sites, all off of portable generators. And what we find is that there's quite a range of quality in the generator side of the business as well. And so it could either be a poorly maintained generator or the improper line cable or any combination of that that can ultimately impact what's happening with that welding machine. It can cause damage, but even if it's slightly improper voltage, whether it's over voltage or under voltage, we found that it still can impact some of these welding parameters. And at the end of the day, if the operator isn't aware of some of these changes, then it can impact that quality, but they wouldn't even really be aware of it. So now we're recording this information in the background, and so we can find and be able to track that information. And also at the same time, we're capturing GPS coordinates. And really we're doing this as a way to be able to say, okay, we're working on this project. We're capturing the GPS coordinates at the beginning and the end of each welding seam, again, to sort of corroborate this is where we've captured this information. This is where this information is coming from. So we're able to take and harvest this data and analyze it. So there's a tool, a mechanism within the My Leister app that allows for the data to be analyzed on screen, whether it's through the mobile device or through the desktop. And then at the conclusion, we're able to take this data that's been harvested and create a data report from it. So it's the ability to take and create a PDF or CSV file that is, on one hand, an archive record of what transpired during the welding process on a project. At the same time, it's also shareable. So if there's any other individuals that may have an interest in what happened with this welding process, perhaps it's a building owner, perhaps it's an architect or a roof consultant, perhaps it's someone from the manufacturing community that may also either want or need access to that welding data, it's shareable to anyone who would want to have access. Contractor has the ability then to use this as a tool as well. Say, okay, I possess this data. At the end of the project, let's go back, let's review the data. If there's anything, any anomalies, anything that looks like it's out of line, let's use this as a tool to go back one more time. Let's check to make sure that everything looks good from a quality control standpoint before we take our last step off of this roof and move on to our next project. The other thing that happens, let's be honest, sometimes it could be years down the road, could be incidents that happen, something happens that maybe questions workmanship or quality down the road. This contractor now has an archive of what they did, which would capture all the information about temperatures and speeds and that sort of thing, and they can come back and they can say, here's what we did. One of the other key features in the machine is a feature that we call Monitored Welding Assistant. So what's happening with Monitored Welding Assistant is gives the user the ability to go into the display and set parameter limit ranges plus or minus for those key parameters like the temperature and the speed and the airflow. So they can create a range plus or minus from those set points. The thought process behind this is that, if there's anything that happens during the active welding process, whether it be a mechanical issue or electronic issue that would take one of those settings and move it outside of that parameter range, you're going to get an audible alarm and a visible flashing red display that's going to provide information in real time to the operator that would say, hey, whatever's happening here may possibly affect weld quality. Our temperature has changed beyond a certain point. Maybe we've moved outside of our welding window. It's possible that whatever's happening here could affect weld quality. So the thought process would be, let's stop the welding process. Let's assess conditions. Let's take corrective actions before we continue the welding process any further. So it's a bit of a stopgap measure right there, right in real time to tell the operator, we should stop the welding process. Let's assess before we go any further. There's an additional feature that's built in as well. They choose to activate it. It's called Stop Device on Alert. It's tied directly to this monitored welding assistant. So if Stop Device on Alert is active, that monitored welding assistant is activated and the operator takes no action, within 30 seconds, the machine will then go into shutdown and cool down mode. So again, as a safety net, to just say, hey, listen, something's happening here that we should not be continuing. The machine will shut itself down. You know, one of the other key features to the machine is what we call recipe management. So what this allows users to do is create their own custom welding recipes. Really all we're doing is creating combinations of temperature, speed, and airflow. And so you're going to have different ambient conditions. You're going to have different membrane mill thicknesses and that type of thing. And so it requires different combinations or recipes or combinations of those three welding parameters. And so the user then has the ability to go in and create these custom recipes right in the Leister app. Those can be then transferred and saved onto the individual machines. Those recipes can be saved directly into the display as well. But what it allows you to do is, let's say you have 3 machines, you can create these custom recipes and you can drop them onto all 3 of the machines that you would have in your fleet. And that way, everybody who's operating is kind of, in a sense, working out of the same hymnal. So, you know, if we're working on a hot summer day and we're using say a standard, 60 mil TPO, superintendent or whatever can say, okay, we're going to use XYZ number 1 today as our starting parameter. And again, I kind of stress that these are starting parameters, right? Because we get asked very often by users, what welding temperature should I be doing? What speed should I be doing? And it's really almost an infinite combination, and it's unique to the individual day. If users are doing their due diligence, they're running test welds every day before they ever do any production work. So we don't want to say that this technology is a replacement for still doing their due diligence and following best practices as it relates to the welding process. I like to think that sometimes people think technology can begin to replace certain activities and responsibilities that you might have. And I automatically think of like self-driving, right? So it's like, if I think that self-driving, is the be all end all, and that I'm always going to get into a vehicle that's self-driving, I'm going to make it home safe. So go ahead, Dave, go ahead and sleep the rest of the way on the way home. I would be very stressed out about that. And I equate this to the same thing. It's like, yeah, these technologies are fantastic, but it doesn't remove the end users from responsibility for taking the responsibility for quality management, quality control, and doing all the right things and following all the best practices that they've learned in the industry. So how does someone get started with the process? So step number 1, if you're going to be buying your first LQS-enabled machine, you want to download the Leister app. It's available on Android, iOS, or Windows versions. So you can run it on a mobile device, you can run it on a tablet, you can run it on a desktop, on a laptop. And step number 2, after the app is downloaded, is to create a cloud account, a Leister cloud account. So again, I typically recommend that users maybe consider creating a generic Gmail account that could be a universally shared login for those in the organization that might ultimately need to use this information and use this data. So moving beyond that, just give you an idea, after the app is set up, this is what the dashboard looks like on the mobile and the desktop versions. So I own my device now. What's the next step after I've set up my cloud account? It's time to start registering the machine. So they would use this device icon to enter into the menu system within the system. And you'll see there's an opportunity then to hit register new machine. At that point in time, you just follow the on-screen prompts. And now that machine is going to be paired to your cloud account. So a lot of people ask, well, how does the communication take place between my mobile device and this new welding machine? Well, it utilizes Wi-Fi technology. So each machine will put off its own unique Wi-Fi signal that will be picked up by the mobile device running the Leister app. So when it's time to connect and synchronize, it's as simple as going into the app, into the LQS portion of the app, and clicking on search devices. At that point in time, the mobile device begins to search and look for that Wi-Fi signal. The machine needs to be on in order to do that. And so when that connection is made, what they'll see then is the machine turn green. So that's an indicator then that that machine is actively connected to that mobile device running the app. So let's just say that on my first time I've used it, I've run, my series of welds that day, and I'm interested in getting access to that data. Well, how does that happen? How do I get a hold of that information? Because right now it's on the machine. So the next step in the process, now that I've connected to my machine, I'm going to do a synchronization. So I'm going to sync to the machine, just simple click of that button right there. So what that'll do is it'll pull the information from the machine. It'll bring the data into the app on that mobile device. So really all the mobile device has to be is within Wi-Fi range of that machine. And at this point, a lot of people will ask, well, how often do I have to do this? I mean, do I need to do this every 10 minutes? Do I need to do it once a day, once a week? It really is up to the end user to decide how often they want or need to have access to it. There's really no hard and fast rule about this. So after this information is in the mobile device, it's currently only in that one mobile device. So anybody else, no one else has access to it. It's just on that one device. So the way that it gets shared and becomes shareable with everyone who is a user or a potential user is to then synchronize this mobile device to the cloud account. So in the upper right-hand corner of the app, you'll see a cloud. So when this mobile device is in the presence of a Wi-Fi signal that has internet connection, so let's just say we are connected to our machine, we shut the machine off, so we cut that Wi-Fi connection. When we're in presence, doesn't have to be immediately, it could be when you get home or when you get back to the office or wherever. When you're in the presence of an internet connection via Wi-Fi, you hit that cloud, and then it takes that data and it puts it into the joint cloud account. So that now anyone else could be in the office, could be in an office in another state. If they're running the My Leister app, they use that joint login credential, log into their My Leister account, click the cloud to sync to the cloud account. That information then comes into their app version. So they can look at it again, whether they do that on a mobile device, whether they do it on a desktop, doesn't really matter. So what's it look like when we want to review and take a look at the data once it's been pulled from the machine? So again, we're in the LQS portion of the app, and we click on the machine that was just used. You'll see the date stamp and the records that were pulled at that time. And so if you click on the first line, line 1, when you click on it, there'll be a button that'll show Analyze. So this gives you the ability to analyze the data right in the app. So again, you can do this from the mobile device. You can do this from the desktop version. We're on the mobile device today. So after I click Analyze, the next screen that I will see will be a table. And it's a table that allows the user to basically archive and document all the details about the project they're working on. So there's an opportunity to click Add, which will be a way to name and create their project name that they're working on. And so it gives the opportunity to all sorts of information that could be populated in there about your company, about your client, about what kind of roof system is being installed, from membrane, the roof deck, ambient conditions on that day, you name it, A to Z. There's even a comment section at the bottom to add any other remarks that would be notable and something that you would want to make sure that you were documenting on that day. So to move beyond that screen, you're going to have to name the construction project in order to be able to move past the screen. So you click Next. That'll take you into your first welding record. Okay, so what the welding records look like are basically like a series of EKGs. There's an individual graph for each of those captured parameters. We talked about temperature, speed, airflow, and the incoming voltage. So it's a drop-down menu that allows you to move from weld to weld, each one independently showing what was documented for those 4 key welding parameters. And then finally, the last is a screen at the conclusion that would be kind of a summary record of all the different records that were pulled in. So I know in my particular instance and in my vision, I prefer to view the data whenever possible on the larger desktop version. So what I'll do is I'll take an opportunity here to kind of walk you through what the desktop version is live. So I'm going to go ahead and jump to my Leister app that I'm running on my computer, and we'll kind of walk through some of these same screens again, just to give you an idea as to how easy this is to work with. So again, if I want to view and analyze the data, it was as simple as going into the LQS tab, where I see the machines that I have in my inventory. So I'll go ahead and click on this first one, and it'll give me, again, the opportunity to take a look at the welding records. So if I do this, I click and I analyze. So I can analyze, again, right on screen. So this is the table I was mentioning before, where I have opportunity to document all the different information about the project. Now, I took the liberty before I started today to name a new project, the RT3 project. And so what this allows me to do is create this project. And let's say this project goes on for 2 months. Every time that I retrieve data and I want to move it into the My Leister app, it allows me to go back and simply, refer back to the same project that I'm working on with the dropdown, rather than creating, a new one every single time I do this. It keeps it all together. So again, this gives you an idea of all the different information that we can populate in and save relative to the work that we're doing. So then to move beyond, we simply click the next, and this gives us our first welding record. So again, as I mentioned, you're going to see each of these parameters documented over distance. So what we're looking for, ideally, under ideal conditions, right? We're looking for nice, straight, flat, consistent parameters. No deviations, no anomalies. I know normally when I use the EKG analogy, we normally say, yeah, in this particular case, we're looking for flat line. Normally we're not, right? But today we're looking for flat line. So this is something that I wouldn't be that worried about, right? Everything nice and consistent, including my incoming voltage. Okay. So let's take an example of a case where maybe we had something happen on one of the welds where the monitored welding assistant activated. So let's say we were actively welding and something happened that took one of our key welding parameters, again, outside of that range that we had established going in. Well, when that happens, that information is also archived and shown in the data report. How does that look? So I go to weld number 2. Let's say the monitored welding assistant went off because there was a temperature deviation. It would appear in the data table like this, okay? And again, it's over distance and time, so we would see that over these distance intervals, this is where we had our incident. Now, one of the things to think about, we would hope that these would be relatively limited in scope, because again, the thought process was when that monitored welding assistant went off, we stopped the welding process and we didn't continue to go. And so we would hope then that people took the corrective action necessary at that point in time and mitigate the amount of time that we were outside of our desired parameter range. Okay. So again, the next one can be viewed. Again, this one appears to be normal, as we would hope and expect. So I have this data, but really what I probably care about the most is any of the data where there's these anomalies or these issues that potentially would have come up. So we can get to our information on this much quicker if we utilize this feature called short report. So if I click on this short report right here, what this does is it filters out all the welds that would be categorized as good. Those are the green flat line ones. And so now the only thing that's going to remain in my drop down will be any of the ones where we had an incident. So it helps us sort of just drill down right away and let's figure out where again do we think we had some incidents. Okay. So we move on beyond this into the summary table, where we have some different information still available at our fingertips. So if I go into the records tab, for instance, what this shows me, again, for each weld, it shows me distance intervals, and it captures a snapshot in time at that distance down the seam, what my temperature, speed, airflow, and voltage was, as well as my GPS coordinates. Now, in this particular example, I didn't capture any GPS because I was running this indoors, so I didn't have a GPS signal. So that's weld number 1. And if I want to check weld number 2, I'm capturing the same information, but I will notice here anything that shows up in red would be an indicator that I was outside of my parameter range at that certain distance interval. Again, this is just a way to be able to narrow down and focus where we think there may potentially be a problem. Maybe there's not, but we're going to be able to use this information as a safety net to go back and say, hey, let's go find weld number 2 and let's double check that seam again and make sure that we're all good before we take that last step off of our project, and so forth. The welding seams tab right here, if we go ahead and click on this, one of the things you'll notice here is we have each individual seam numbered, and it provides us the total distance of that seam, also latitude and longitude. Now here, this is the oh, by the way part of the technology that I also like to make sure that I point out to contractors, because this gives a contractor an opportunity to actually pull productivity information out of this. Now, we didn't really build this as a productivity tool or a productivity measuring tool, but the oh, by the way is it's there, right? So if I harvest my data, let's say at the end of every day, I can go back into the data and I could say, okay, well, we did 21 welds today and it totaled X number of lineal feet. Well, I could begin to use that as some sort of productivity gauge. So, you know, we didn't bring it out as a productivity tool, but it's certainly worth mentioning to the contractors. So when I'm all done viewing and looking at my data, I have the ability to save it. So I simply click down here on the save button, and that allows me to save this as a PDF or a CSV file again, so that I can archive this or share it, should someone be interested. So once I've created and shared, I also have, it will share with you what a finished data report looks like. So again, this comes up in PDF version. So again, here's my table that I described earlier that captures all the information that I populated in about the project. It's going to show all the summaries. It's going to show each weld, and the same information that you were able to look at on screen, you now have in PDF form. Now, one of the things I want to point out here is that we have the same summaries as I pointed out before, but in this particular instance, we have captured latitude and longitude. So in the PDF version, all the latitude and longitudes are hyperlinked. So we have the ability to go in and click through, and this will take us through to Google Maps, and it will drop a pin on the location. So in this particular case, we go ahead and we can zoom in. GPS technology being what it is, I don't think it's going to drop us within inches of our seam, but it is going to place us probably within about 10, 12 feet or so of our welding seam. Just to give you an idea, on this particular example, I was welding right here as a demonstration right on this garage apron, and I'm about 10 feet away from that pin. So we've been asked before, well, how, as a contractor, am I to be able to identify weld number 2, if that's the problem weld? So we don't possess a software program where we've been asked before, like, oh, can you do an as-built drawing? Can we do an overlay where we're able to see our welding seams overlaid a Google Earth or a Google map? We don't possess that ability today. So we're telling contractors it is going to be incumbent upon them to do their due diligence and kind of map out and lay out and track how they're doing their welding on each different section of the roof, so that if and when they need to compare and contrast against a data report, they're able to go back and follow what they did and do that check. So that gives you kind of a high-level overview of the data and how things are captured and whatnot. I'm not sure if anybody has any additional questions. I've kind of thrown quite a bit at everyone, but I'm greatly appreciative of the time that everybody gave to have me speak with you today. So I don't know, Karen, if
Yeah,
there's any
Dave,
other questions or whatnot, I'm happy to answer them.
there is a question in the chat that says seam preparation is the equivalent of the test weld, correct? And could we upload a photo to attach to the report?
You know, I'm going to have to probably double check to see if they have ability to attach anything to it. But yeah, I mean, I think it could still be bundled, you know, so that it's together, you know, and date and time stamped so that things can be, you know, correlated. But I will have to double check, and maybe Karen, I'll work back through you to let you know if there's a way that we can have something else added in externally into the report related to something like that. But yeah, the test welds, I mean, that, you know, that's something that, you know, I've spent quite a bit of time with, you know, different material manufacturers, you know, here working through their training programs and that sort of thing. But that's something that's a drumbeat that they beat all the time, you know, about doing the due diligence at the beginning of every day or any major break. Don't make any assumptions about, you know, what's going to work this time. Test it again. Make sure you're probing all your seams again. It's just a best practice that this doesn't substitute for it. It just enhances it.
I also one of the questions I had earlier when Dave and I were reviewing this was, with the built-in Wi-Fi, is there a cost? Because, you know, and there's not, right?
There is no cost, correct. You know, we had explored at one time the possibility of making the service a subscription service, and we backed off of that quite a while ago. So if you buy an LQS enabled machine, you download the app, it's free to download, and there is no additional service for the connectivity moving forward.
Can old Leisters be retrofitted with the technology?
Actually, no. So right now we have one machine out. It's the Uniroof 700 that is the LQS enabled. But you know, we definitely have plans to integrate this into machines that we'll be developing into the future. So it will continue to be advanced with our industry as we our industry offering as soon as we begin to develop upgraded and newer products.
All right, off-topic question, but still relevant for you. Is there plans to have a battery-operated version of the Leister hand welder for service and repair?
I get asked this a lot. You know, battery technologies have been advancing rapidly for years, and you know, we recognize where this niche is in the marketplace and the value of having it. I mean, we see it particularly targeted toward, you know, the repair crews and that sort of thing who just need, you know, 30 or 45 minutes of runtime. There's also a lot of physics and science behind this as well. When you're talking about trying to harness battery power and heat something up to 1,200 degrees and sustain that for a prolonged period of time, to do it safely, to do it ergonomically, and at the same time be aware and cognizant of cost. You know, I mean, so I'll just go as far as saying this. I mean, it's an active project that we are looking at and working on. We don't have a solution ready for the marketplace today, but it's something that we do see some value in, and we do see the need for it. So something that we're going to continue to work on and see if we can advance.
Excellent. Thank you, Dave. Dave's contact information is up there. Oh, Jill, I don't know, skip your question. Does it show where you have had an improper weld? I think you have to kind of deduce that from the distance, right, Dave?
Yes. Again, the data table will give you snapshots of distance and time. So really what it boils down to, as I mentioned before, the contractor is going to have to do their due diligence again to sort of, you know, have a separate running data information about how they laid the roof up and how they mapped out their welds, so that, again, if we had an issue on weld number 17, that they could go back onto that roof section, they could go find weld 17, and then the data will say that, you know, if it was an issue where the monitored welding system went off, it'll be at distance intervals, and it'll tell you from this distance to this distance is when we were outside of that parameter range. And so you know, at that point in time, you know, it's best to just go back and check. You know, for me, I would check the whole seam, but just again, you know, before I take that last step off the roof, I'd like to know, I'd sleep better at night knowing that, you know, we checked it one more time before we walked away.
Yeah. Yeah. I think one of the things that you and I talked about earlier, Dave, was the fact that this can also be used on the front end as a sales tool. When you are, bidding a job, then this is something you can show as your commitment level to the quality control of the installation.
Yeah, absolutely. I mean, really what this does is it provides, a contractor the opportunity to offer very transparent, record of what we do. So, they're already, very forward thinking, proactive, contractors are already running very advanced, safety programs and all that. And so if they're, wanting to add something into their arsenal, if they're sitting in front of a building owner or something, and they want to say, well, here's all the things that we do, this would be another thing that we do. We say, we're very quality minded. As part of our overall quality management program, we are monitoring and recording all of our welding data so that we're utilizing this technology to make sure that we have the tools at our fingertips for information in real time. We're also archiving what we're doing, so we make sure that we, can look, down the road, sit before you and say, here's what we did.
Excellent. Well, thank you, Dave. This was really, really
Can I ask one more question?
Oh, yeah, sure, Jill.
So Dave, can you show me that report again? So when you have an improper weld, is that the part can you show that to me again?
Absolutely.
So
I'll just back up
in your presentation. So it shows up red so the contractor will know. I want to make sure I understand.
Let me go. Yeah, let me go. I'll go into the app and then get through it faster.
So when they see this, so now it's a green line, so they'll be able to easily tell, because it turns red. Is that what it does? Is that, if I understood correctly?
So yeah, so in the data, so in this particular instance, Jill, what you see is down here on the bottom axis, it's the distance down the seam.
Yeah.
So it's showing here that just slightly after 150 inches down the seam, we had our first alarm go off with the monitored welding, and we're basically outside of our limit range all the way up to about 200 inches down. So in that, say, roughly 50-inch stretch. So it would be visible not only in the table like this with the graphically, but then if we also go to the records tab, and this is also giving us the same seam. These are distance intervals down that seam, and at every interval where we were outside of our range, it'll show in red, like it's right here or right here. So we know that 153 and 157 inches down the seam, the machine was telling us that at that moment we were outside of our parameter range. And basically it also really continued on from 169 all the way down to 192. So this would be what I would lean on right here.
Yeah.
I know it's weld number 2, and this will tell me in the areas where I was outside of my range. I would probably just, as a best practice, I'd stretch that out beyond that, but
yeah,
this is where I'm going to pull the data from.
So does that mean that the heat wasn't quite right at that moment? Is that what causes the alarm to go off?
Yeah. So let's just say I set my range at 36 degrees Fahrenheit plus or minus. So let's say I set at 1,000 degrees. So once I'm at 1,037 or 37 below that, that's what's going to trigger that monitored welding. So I could be in that range and still be okay. But once I surpass that 36 degrees plus or minus, that's going to trigger it. So it's really kind of up to the contractor to kind of have a feel for the membranes they work with and how friendly their welding windows are, right? So if they want, hey, listen, the material manufacturers have worked hard over the last several years to tweak their formulations and make their membranes very, very friendly, over a lot of different, temperature and speed combinations. And so, it's just up to the contractor to say, where's my comfort level? If I go beyond this is where I want to be. But if I go beyond this point or this point, then I'm going to be a little bit concerned. This isn't even going to guarantee that it's a problem. It's just warned you that it's beyond
outside of that range,
your comfort level, right? So you might go back and it might probe out fine. You might even do a cross, T-peel test, and it might peel out fine. We're all good. We'll have to patch it, whatever. So it's not going to guarantee that it's a bad weld. It's going to just warn you that, it's worth checking.
And how hot does it need to be to actually catch the roof on fire compared to what the heat that you're at?
I don't necessarily possess that exact data. You know, we know that, you know, it's under extreme conditions. Let's say that, you know, a nozzle's inserted, but something happens that affects the drive, or it's an unattended machine. I mean, these are typically all mostly negligence driven issues. You know, PVC isn't quite, has the same level of flammability, I believe, that the TPO does. But nonetheless, it becomes very evident very quickly. I mean, and again, because of the way that we've advanced the machines and whatnot, you know, we have conversations with contractors all the time about, you know, where do you really need to be today to be successful in the welding process? Because, you know, I think especially in the case of TPO, you can actually run these machines too hot. I mean, I know they're able to go up to, say, 1148 degrees, but again, the machines, or the membranes, are very friendly today, and sometimes you end up getting much better welding results at lower temperatures, maybe a little bit of a lower speed, and you avoid that concern about scorching the membrane or overheating it to a point where you end up not being able to weld it anymore.
This is awesome. Thank you so much for sharing this.
My pleasure.
Thanks. And I am recording this, and I will get it out on our YouTube channel and share that link with anybody. So if there is anyone that you would like to share the presentation with, you'll be able to do that. Dave, thank you very much for sharing this with us.
Thank you, everyone, for being here. I appreciate it.
It was really interesting. All right. I am going to